Hello friends, welcome to our channel. Let's look at problem 3540, minimum time to visit all houses. In this video, I'm going to explain how to solve it using partial sums. So here the partial sum can be prefix sum or can be suffix sum. And especially here, the houses are arranged in a circle, right? So what we want to return is, given this query, so we want to return the minimum total time taken to visit the houses according to this query, and initially starting from house 0. So here, the constraints are the following. First, n is at least 2, and bounded above by 10 to the power 5. So this says that n can be as large as 10 to the power 5. Therefore, we need to think of time complexity. So the others you can understand as consistency assumptions. So with that said, I guess we are ready to explain the main idea, and then we do the coding. So here, our goal is to build two partial sums, and then for each of the consecutive houses in the query, so we want to check if we from I to array j, if we do it in a clockwise fashion, so what's the time? And if we are going to use counterclockwise, so what's so it's clock, right? Not close, clockwise. So what's the time? And then each time we are going to pick the minimum smaller of these two. So that's basically the main idea. So actually, for this, due to the indexing, it takes me some more minutes to write down a fully correct solution. Because of this, I'm going to explain and write the code with some details so that we know or digest the final detail. First, I'm going to get the length of this forward. So first, I'm going to do a clockwise check. Clockwise. So here I'm going to define a list, so which has length n plus 1, right? So basically I want to get from the index, so to arrive from index 0 to arrive at a house I. Index means house, right? So I would use it index and the house interchangeably. So from house 0 to arrive at any house, what's the time? So in order to do this, so we're going to first define like this for I in range, so from 1 to n plus 1. So this ends at n, right? So here, because we are dealing with this bullet point, right? So house I is connected to house I plus 1 via a road with length forward I. Therefore, so fi, so let me distinguish if I is not n. So we are going to write fi equals forward I minus 1. So this is so here house I is connected to house, whereas this, if it's were I, so this is would be I minus 1, right? So this is the one. Otherwise, if I equals n, right? Essentially you are dealing with fn. So fn, so we're going to write forward, say I minus 1, actually n minus 1, right? So this is the dealing with here. So the house via a road with length for this one. House n minus 1 is connected back to house 0 via this, right? So this is completing a circle. So this is the one. So in order to compute from the index 0 to any index, the time, the distance. Actually, the distance can be interpreted in numerics as time, because the speed is 1 meter per second. You know, the units are different, but the numerical value are the same. So here I need to do a cumulative sum. So this is actually very easy. So for I in range, so 1 n plus 1. So what I'm going to do is this. So fi increment by the previous one, right? So here actually you can print out this f. So here I'm using f string. So what we get? Forward. Let me forward. Right. So this one, from 0 to 0, you just 0 distance to arrive at in the house 1. So this is the 1. So from 0 to arrive at house 2. So this is the 5. Arrive this one. This will be none. But we are not going to do this directly. So we are going to interpret. Once we go to the index 2, we are going to move to index 0. So this is the 1. So next, what we are going to do? So we do the same thing, but we do counterclockwise. So the role of this f is that given any two indices I, j, no matter it's I is greater than j or less than j, so we can compute the time taken from I to j using this array. So you will see how we will do that. So also we want to prepare the counterclockwise one. So I'm going to use backwards, right? So it's 0 times m plus 1. So here I'm going to do this for I in range, so m minus 1, negative 1 to 1. Because here is the end point. We end before negative 1. That is, we end at 0, right? So if I is not 0, so we are going to use this. House I is connected to house I minus 1, where this, right? So what we are going to do is b I minus 1. So arrive at b I minus 1. So we'll be backwards I, right? So that's otherwise. So we are going to do bn minus so bn minus 1. So I'm going to set it to be backward backward I. So then I'm going to compute the cumulative sum again. So for I in range, so 1 not 1. So here I'm going to reverse. So here n minus 1, negative 1, negative 1, right? So b I increment by that of b I plus 1, right? So you can also print out b just to get a feeling about what's this. Right, so this will be b, right? So in order to have this at index 2, so you get 4, right? So then you are going to get 2, and then you're going to get 1, right? So next, what we want to do is to write the two functions. So here, actually you can do a check. So let me print out this 2 again. So f and b, right? So we can check actually. So for example, if we want to start from 2 to 1, let's see. Let's see from I to j. So here, for example, if we want to from 0 to 1, so actually this will be let me first from 0 to 1, you're going to use 1 time unit. So in this you are going to use this f1 minus f0, right? So if you want to from 0 to 2, right? This will be in if you use b is clockwise, so this will be f2 minus f0. That's 5, right? So then if you want to do from say 2 to 1, right? If you want to follow this this f, so from 2 to 1, actually it takes 5, right? So how could we get this 5 from 2 to 1? So first we actually we do this. So let me let me write like this. So it will be f at n, right? The length minus, because 2 is larger than this one, right? So I'm going to use this 2, and then I'm going to use f1 minus f0. So we first arrive at the last, and then we interpret that as n. So at the same time, we also regard it as a beginning. So if you see this, so this minus f2, that's the 4, right? So then f1 minus 0 is b1, that's 5. From 2 to 1 is 5 if you check this forward. This is the right one. So similarly, you can check for b. So in order to make it modularized, I'm going to write 2 functions. So one is called clockwise move from I to j, right? So first, if I is less than or equal to j, so what we want to do is just fj minus fi, right? That's actually the rule why we construct this f. Otherwise, so because clockwise, we hope that we from small to larger. But if I is greater than j, so it means that we first need to move to n. So also n is 0, right? And then we move to I. So this will be the thing that we return. So fn minus fi and plus f, because fi is larger, so n is larger than I, right? So we use larger index minus smaller index. So then we have fi minus f0. So actually, if you see here, the f0 is always 0, but f0 is 0. But let me keep this format because this will be more symmetric. So here it's not I, it's j, right? Otherwise, it will cancel, right? You will always have fn minus f0, a constant. So this is for clock move. Then counterclock move. So from I to j. So this, if I is greater than or equal to j, this is natural. So we are going to return b, the smaller one, minus the larger one. So smaller one is j, larger one is I, right? So you see here in this b, the smaller the index, the larger the sum, right? That's why we use smaller minus larger. So otherwise, that is I is less than j, right? So in other words, we need to first I move to 0. Then we immediately interpret 0 as n, right? And then we move to j, right? So in this case, because I is less than j, but I is for sure so I is less than j, and but I is greater than 0, right? So therefore we can do b naught minus bi, right? And then we know 0 is less than j, so we're going to use the n is greater than j, right? So we're going to use so bj minus so here first we interpret at 0 and then at n, because j is less than n, I'm going to use smaller one minus larger one. So you see this two, the return here and the return here are actually symmetric. If you do some direction reversing your mind, you are going to notice that, because clockwise and counterclockwise are relative, right? If you define one direction is clockwise and then the other direction is the counterclockwise. So with the help of these two functions, we make things modularized. And then we are going to do the return. So we have result, and then for I in range length of the queries, right? So we know the end will be queries I, right? The start is I'm going to write it as queries I minus 1 if I is greater than 0, right? Otherwise, so we just start from 0. Then each intermediate, for example, from this house to this house, so we are going to find the smaller of these two, right? So what we do is smaller. So we can have min this one. This is the clockwise. So you can have S and E, and then you have counterclockwise. You have S and E, right? So then this will be the result. So now you can do a return to the result. Before we make some comments, let me first test if it works. So the second one is not right. Let me check where I made mistake. So first, so we have this f n to n minus 1. So let's look at the index, right? If I not equals to n, fi goes forward I minus 1. Otherwise, fn is, so here is -1. So let me check again. Still, let me see, still have other places. That's not right. So let's say b. It's the n minus 1, -1. It's also right. It's not 0. We get this. So here, if this, so n plus 1, so n minus 1, -1, -1. That's right. Backwards I is also right. So and bi plus 1. Yes. So now let's look at these definitions. So clockwise, if I is less than or equal to g, so g minus I. So then we have fn minus fg plus fg minus f naught. Fg, so here actually I guess I got me. So I is greater than 1, so I guess this should be the right one. Right, let me test again. Yeah, it passes all the cases. Now let's look at the generic case. Yeah, it passes all the cases. So let me make 2 comments. First comment is that, so for this clockwise and counterclockwise, so actually if you use Python, there are some functions called accumulate sum. You can directly write it using that built-in function. However, here we want to expose to you the details and the thought process. So this is the one. So another one is that you can actually retrieve the procedure. Let me use these 2 examples to explain to you. So here you can do some prints. So print. So let's use f string. So I equals, and then what's the start? So s equals, and e equals, and clock says move. Let's see. So I'm going to write like this. Clockwise. So I'm also going to have counter clock. So I'm going to have this one, right? Let's see if I print. Yeah, I guess this should be enough. So let me run it. So let's compare with the explanation here, right? So when I equals 0, so you are going to move from house 0 to house 1, right? So the increment is 1. So we know the smaller one of these 2 must be 1. So this is not this example. Let's see. And this one, right? The smaller will be 1. And then from 1 to 2, the increment is 4. So the smaller of counter or clock will be 4. So from 1 to 2, so this smaller is 4. Then from 2 to 1, and so the increment is 2. Let's see, from 2 to 0, right? So here he wrote the root, but here from 5 to 8 is 3. So here smaller is 3, counterclockwise, right? Then from 0 to 2, so the increment is 4, right? It's also counterclockwise. So here the root, it will be from 0 to 1, we do clockwise travel. And from 1 to 2, we do clockwise travel. And from 2 to 0, counterclockwise. From 0 to 2, still counterclockwise. So overall, you will get 1 plus 4 plus 3 plus 4, right? That is 12. So you can also check case 2. This is rather simple because this 1, 1, 1, 1, no matter what is only 4, so it's smaller. So from node 0 to 1, so clockwise, 1 to 2 clockwise, 2 to 3 clockwise, 3 to 0 clockwise. So the total is 4. So actually, up to now, we explained the coding details and also print out some useful information for us to retrieve the explanations here. I guess with that said, that's about it for this, I would say, interesting problem. But here, actually, we're using the partial sums to make some pre-computations so that we can find the travel time or the travel distance clockwise or counterclockwise for any two horses, just by retrieving the indices of the two partial sums like f and b, right? With that said, I guess the video is already too long. I will stop here. Thank you for watching.